You'd never guess it, but we're about to hit another blood pressure topic. Blood pressure is essentially regulated via two mechanisms, on a second-to-second basis with the nervous system and over the time via the kidneys. You will get these specific mechanisms during the renal module, but they essentially deal with total water level and salt control. For today's cardio section, we will focus on the neural control aspect of blood pressure control. The neural control is a set of reflexes based on a negative feedback mechanism. The one on the arterial side is the baroreceptor reflex. These are pressure sensors located in the aortic arch and the carotid bifurcation. Normally, they regulate the system around a based set point of 95 to 100 millimeters of mercury. But over time, if there is excess stimulation, the reflex response can tire out and move the set point. When the carotid and aortic bodies are stretched, a signal is sent via cranial nerve 9 and 10 respectively. This stimulus activates the parasympathetic nervous system and decreases the system's sympathetic output. Activating the parasympathetic nervous system will decrease the heart rate, acting at the SA node. This is negative chronotropy. And it also acts at the AV node and is a negative dromotropic influence. Decreasing the sympathetic input has the same effect as the parasympathetic nervous system, but the sympathetic system also regulates the squeeze and the vessel tone, so decreases in sympathetic input will decrease the squeeze and decrease the vessel tone. However, if these baroreceptors are not adequately stimulated, then the body senses a drop in the cardiac output. The pre-existing stimulus that was coming from cranial nerves 9 and 10 is decreased. This is called a drop in the vagal tone. This reflex also increases the sympathetic output to the heart and vessels. There is venoconstriction that increases the preload that primes the Frank-Starling response. The increased sympathetic output of the heart also increases the rate and its contractility. When the arterial pressure rises back to its set point, the vagal tone returns and the system resets. It is going to be important to understand the cause and effect relationship with pressure and heart rate. If we increase the pressure in the system, then there is a reflex to decrease the heart rate, and vice versa. However, if we increase the heart rate, then we will increase the pressure in the system. Remember back to your lecture yesterday when pure increases in the heart rate increase the diastolic and systolic components by the same amount. Pay attention to this when you're doing practice problems during class and think about scenarios that elicit each response. Think about what came first, the chicken or the egg. What came first, the drop in blood pressure or the increase in heart rate? Thank you for watching and good luck with your studies.